Click the bell icon to get latest videos from Ekeeda.
Hello friends, in the previous session we actually studied about the chemical concentrations and the construction of a blast furnace. A blast furnace is extremely important to extract the iron from its ore. Today we are going to study about the exact working that happens in the blast furnace, all the chemical reactions which happen in the blast furnace, and also the formation of pig iron, which is also known as one of the purest forms of ions one can get from the blast furnace. Working of the blast furnace. The hot blast of air is introduced from the tubers into the furnace and charge is fed from the top of the furnace through cup and cone arrangement. For this, first let us see the entire diagram of blast furnace. So over here when we see, when they are talking about tubers, these are the tubers. Now what exactly tubers do? They pour in or they blast in hot air into the blast furnace. Now what exactly happens in the blast furnace? There is a cup and cone arrangement for the floor. What is a floor? Floor is nothing but by ore and coke in it. So the ore and the coke comes through the cup and cone arrangement inside the blast furnace. Because of this cup and cone arrangement, small amounts of ore come periodically into the blast furnace. So because of that, it comes inside, and once it comes inside, it is subjected to the hot blast of air. So when this hot blast of air and this mix together, what happens exactly is there is ore, there is coke, there is air. That means there is oxygen, there is heat, there is coal, and there is ore. That means different reactions keep on happening, and because of that all the reactions happen in this area with the help of the air which is coming over here. And these two tubers not only blow in air, but they blow in air with very high temperature of around 800 degrees Celsius. That means they're not only helping this with air but also helping it with the heat which is provided, and that is the reason why we have oxygen, we have heat, and from here we get our ore and coke and all the reactions take place. Now let us exactly see how the reactions are taking place inside the blast furnace. Near the tubers, the coke burns in the blast of hot air to form carbon dioxide with the evolution of large amount of heat, that is exothermic reaction. Now what exactly happens over here is from the top I have my charge which is coming down, from the down the hot air is coming up, and because of that the carbon meets oxygen at high temperature. When carbon meets oxygen at high temperature, the carbon gets oxidized, and when the carbon gets oxidized, there is only one thing it can form, which is carbon dioxide. When carbon, heat and excess of oxygen, the product is always carbon dioxide. But if carbon, heat and the oxygen is limiting, then it is carbon monoxide. But over here we are providing excess of oxygen with the help of two tubers which are present at the bottom, and that is the reason why the carbon gets oxidized into carbon dioxide. And this reaction itself, C plus O2, that is CO2, gives heat. 97 kilocalories of heat is being produced because of this. So now what exactly happens over here? I have C plus O2 forming CO2. Now this carbon has got oxidized into CO2, giving me heat. Now it is very important to trap that heat inside the blast furnace. Once the heat is evolved, after that the heat also should be trapped inside the blast furnace, and there is nothing better than carbon dioxide for trapping heat. Carbon dioxide is the only element or the only compound responsible for global warming. Why? Because it traps the heat from the sunlight, and that is the property of carbon dioxide which is used over here. After the heat is evolved, the heat should not just go out of the blast furnace, the heat should be trapped inside the blast furnace so it can help and support the other reactions which take place. So by the first reaction, by the very one, the only reaction, two purposes are being served. The first purpose is the heat is being evolved. The second purpose is the heat has been trapped. When CO2 goes up, it reduced to CO, that is carbon monoxide, by coke present in the charge along with absorption of heat, that is it is an endothermic reaction. Now when CO2 goes up, that means over here when the reaction took place, what exactly happened was C plus O2 formed CO2. Now when C plus O2 forms CO2, the CO2 will be used for trapping the heat. But again, it's a gas, it's a very light gas, and that is the reason why the CO2 will go up. So as it goes up, it cannot just go up and escape out. Why? Because more coke and more flour is being pouring into it, so it will start reacting with that, it will start contributing to that as well, and that will form CO, carbon monoxide. Why? Because when it comes over here, it reaches over here, there is no oxygen here, because the supply of oxygen is at the bottom from here. So since it goes up, there is no much oxygen left and carbon dioxide gets reduced to carbon monoxide. So over here we have CO2 plus C forming 2CO minus 39 kilocalories. Minus 39 kilocalories is nothing but an endothermic reaction and not an exothermic reaction. That means the heat is not being evolved but taken in. And this CO2 with more carbon forms 2CO. Just have a look at the balancing of this. CO2 plus C. Over here on the reactant side I have 2 carbons. On the product side also I have 2 carbons. Over here on the reactant side I have O2. On the product side also I have 2 oxygens. The temperature at the blast furnace goes on decreasing from the bottom to the top. This CO reduces most of the iron oxide into iron metal. The formation of CO, though it is an endothermic process, it is an extremely necessary process. It is very important to form CO2 to CO, to reduce carbon dioxide into carbon monoxide, because we do not need heat if the entire procedure is not happening. The two things that are very important inside the blast furnace is A, to maintain the temperature, and B, to make sure that all the reactions are happening. Imagine the temperature is maintained but the iron or the impurities attached with the iron are not being touched, then there is no point. And that is the reason why, although formation of CO from CO2 reduces the heat which is there inside the blast furnace, but it will also help in the formation of iron. Now let us look at this reaction where Fe2O3, now Fe2O3 is ferric oxide of iron. Why is it ferric oxide? Because we have 3 oxygens over here attached to my iron over here. So now what happens in the ferric oxide plus 3 carbon monoxide? Again, it's a reversible reaction. Why is it a reversible reaction? Because over here there is high temperature and a lot of reactions are keeping on happening, and that is the reason why everything inside the blast furnace is very unstable. So over here we have Fe2O3 plus 3CO forming 2Fe plus 3CO2. When I'm talking about 2Fe, 2Fe is nothing but my pure iron. Over here there is nothing but iron, there is nothing attached to iron, and just because of this carbon monoxide reacting with Fe2O3, reacting with the oxides of Fe2O3, we get the purest form of iron plus 3CO2. So when I'm talking about 3CO2, 3CO2 is nothing but carbon dioxide, and carbon dioxide is nothing but gas. So gas will simply go away, it will evolve into the atmosphere, it will get mixed into the atmosphere. So the only thing remains is 2Fe, which is my main product. So just by the carbon monoxide formation, it will come directly in contact with my Fe2O3 forming my pure Fe. Let us look at the balancing of this equation. We have Fe2O3 plus 3CO forming 2Fe plus 3CO2. On the reactant side, considering both the reactions, how many Fe or how many iron we have? It is 2. On the product side also we have 2 Fe. So Fe is balanced. On the reactant side, how many oxygens do we have? O3 plus 3O. Can you see O3 plus 3O? So over here we have 6 oxygen. Over here let us see 3 into 2. O2 twice. So 2 into 3 or 3 into 2. Again this is 6. So oxygen is also balanced. And lastly we have 3 carbon over here and 3 carbon over here. So overall this is nothing but a balanced equation. Simultaneously, with the process of reduction, a part of metallic ion reacts with CO to form ferric oxide. So what is this reaction exactly? It's a redox reaction. Why? Because over here there is oxidation happening. CO forming CO2, that is addition of oxygen to CO forming CO2, and Fe2O3 forming Fe. That means over here CO gets oxidized to CO2 and Fe2O3 gets reduced to 2Fe, and that is the reason why there is simultaneous reduction and oxidation which is keeping on happening, and that is the reason why this reaction is known as redox reaction. So because of high temperatures and instability, there might be that a part of metallic ion reacts with CO to form ferric oxide again. That means this part can again react and form Fe2O3 again. The backward reaction can be prevented by continuous supply of hot blasts of air. We really need to maintain the temperature because this forward reaction happens at high temperature. The backward reaction may happen at low temperature. That is the reason why we really need to maintain the temperature inside the blast furnace unless and until the entire iron is just taken out. The iron which is taken out from the blast furnace is also extremely high in temperature. It's extremely hot. It has to be cooled for days to solidify and to get its pure form. Why? Because if we try to decrease the temperature inside the blast furnace, the only thing that will happen is this Fe will again convert into Fe2O3, and that is the reason why the proportions and the temperatures are to be taken extremely seriously in the blast furnace. Flux lime forms a slag with impurities and silica. Thus, blast furnace has two functions: A, to reduce the ore to metallic iron, and B, to remove the impurities in the form of slag. Now what exactly happens over here? The ore gets into metallic iron, that means I have the purest form of iron, and B, all the impurities and the slags are easily removed. The molten iron from the blast furnace is collected in molds, and on solidification there is formation of pig iron or cast iron. It is most impure form of iron containing highest percentage of carbon, that is 2 to 5% of carbon. After this also the percentage of carbon is 2 to 5%, which makes it hard and brittle, and hence it is unsuitable for commercial use. Pig iron is used to make wrought iron. Pig iron, or the iron we get from the blast furnace, cannot be used because it is extremely brittle, and that brittleness cannot be used for us, and that is the reason why that pig iron is then converted into wrought iron, and that wrought iron is extremely strong and can be used for our day-to-day activities for domestic as well as industrial purposes. But to make wrought iron, it is very important to have pig iron first. Pig iron is used to make wrought iron, pure form of iron, and steel, and alloy for iron with carbon and various metals. So over here in this video we studied the working of a blast furnace and all the chemical reactions involving in it. Thank you so much for watching this video. Stay tuned to Ekeeda and subscribe to Ekeeda.